Hi, I am Afi. I'm from Group 3. I will present about Torricelli Theorem open-ended experiment. Okay, this is my group members, which are Muhammad Afi bin Muhammad Sabri, Muhammad Aikal bin Badrul Kisam, Don Hazwani binti Muhammad Sabri, Jerawat anak lelaki Pranet, Muhammad Ifan bin Ramizu. Okay, this is a table of contents. If you can see, for introduction, Torricelli theorem is a theorem relating the speed of fluid flowing out of an orifice to the height of fluid above the opening. The physical law describes a major relationship between liquid exit velocity and its height in the container. The law explains the relation between fluid leaving a hole and the liquid height in that container. A simple experiment to test Torricelli laws can also be performed by a soda bottle by puncturing the bottom with a small hole. As the height in the reservoir decreases, the exit velocity decreases. The objective for this experiment is to verify Torricelli relationship by comparing the measure and theoretical value of velocity.
Hi, it's me Haika for this kind of experiment for experiment Torricelli theorem. I would like to present and discuss about the theory section. So please listen carefully so you will understand more about the Torricelli experiment. So let's get started. Torricelli theorem describes the relationship between the velocity of non-viscous fluid flowing out from an orifice under the force of gravity and the height of fluid. So as can we describe from the equation from the definition of the Torricelli theorem, we got velocity of theorem equal to square root of 2 gravity times with gravity and height. The V is velocity, H is depth of below the surface of the liquid, G for the gravity of the fluid. Then, in this experiment, we also can describe the parabolic trajectory. As you can see in the picture, that is we call the parabolic trajectory. In the parabolic trajectory, we got x-axis and the y-axis. So to be define it, parabolic trajectory can be represented using the kinematic equation because the single droplet in the water stream have the same velocity as the fluid exit from the hole. So as you can see, there is x-axis and y-axis. These axes are very important to describe the formula. So next, for the x direction, we can consume the x direction uniform horizontal motion. So the velocity of the water from A to B can be obtained through the equation equal to V equal to delta x over delta t, where delta x is change of x minus and delta t is change of time. Since the water at initial, so the x are at 0. So we can conclude that v equal to x over t. Next, for the y direction, we can assume free fall acceleration is constant over the range of motion and always directed downward. For the effect of the air friction is negligible. So we can conclude that the equation from the y direction is y equal to y naught plus v naught times with t times plus 1 over 2 times with gravity times with time power of 2, which can be derived from S equal to V naught times with T plus 1 over 2 times with gravity times with time power of 2. Since there is no vertical motion at initial state, therefore y naught equal to 0 and v equal to 0. So as we can conclude for this statement, we get y equal to 1 over 2 times with g gravitational times with t power of 2. So we got the x direction equation and the y direction of equation. So if we combine it, we get v measure equal to x square root of g over 2y, where v measured is measured velocity of water, x is maximum horizontal distance traveled by water, g is gravitational acceleration, y is fixed height of nozzle to the ground. So from the equation, we can conclude that the horizontal distance traveled by the water increase when the location of hole getting closer to the ground. Here the ground, here the hole. Due to the pressure exerted on the water, pressure to the water increase with depth. As a result, the strength of water jet is stronger at the bottom of the cylinder. The water flow rate exit from a same hole will decrease as the height of water in the cylinder decrease. As you can see in this picture that is described with this explanation. So I think that's all for the theory part.
Hi, I am Rahazwani. Next, I will continue with the methodology part for this experiment that consists of the apparatus and also the procedure. Okay, so here's our apparatus. As we can see here, we have clay marker, cylindrical cylinder with 3 holes, and also we have measuring tape. Okay, moving on to the procedure. For the first step, the apparatus was set up at the height of 36.65 cm. Okay, as we can see here, this is our first height, which is 36.65 cm. Okay, for the step number 2, the cylindrical tank was filled with 2.00 liter of water, and the hole at cylindrical tank top was covered with the fingers. Okay, so here the first figure show that the cylindrical tank was filled with 2.00 liter of water, and next the figure shows that the hole at cylindrical tank was covered with the fingers. Okay, step number 3, the finger was taken off from the hole, and at the same time, maximum distance of water trajectory was marked with clay, and time in second was recorded. Okay, so as we can see here, the finger was taken off from the hole, and here the maximum distance of water trajectory was marked with clay, and here we record the time in second. Okay, so for the fourth step, step 2 and 3 were repeated with different volume of water, which is 1.75 liter, 1.50 liter, 1.25 liter, and also 1.00 liter. And the last step, step 1 to 4 were repeated with different height of 56.45 cm and also 76.15 cm. That's all from me. Thank you.
Okay, so next we move to the result. The table 1 shows that the height from the floor to the orifice where y1 equal to 36.65 cm. The next table is the height from the floor to the orifice, where y2 equals to 56.45 cm. And the last one is the table about the height from the floor to the orifice, where y3 equal to 76.15 cm. Next, we move to the discussion. For the number one, explain your selection on dependent, independent, and constant variable. Dependent variable is the maximum water trajectory distance, time taken for the water to drain out, and the independent variable is the initial water level, the height of the orifice from the datum point. For the constant variable is the fluid properties. This variable is used to obtain the objective, which is to verify the Torricelli relationship by comparing the measure and theoretical of the velocity. Furthermore, this will be separated into two main parts, which is the initial water level difference towards the water velocity and the orifice height towards the water velocity. For the next discussion, it is to clarify on how you can relate the Bernoulli's equation with the Torricelli's law for this case. Show all the derivation and explain each step. Torricelli's law may be derived from Bernoulli's principle and related to the velocity of fluid leaving the orifice in a fluid filled in the container to the height of the fluid above the orifice. Torricelli's law is derived from the Bernoulli's equation, where the equation 1, the potential energy at the free surface of the fluid, to equation 2, where the kinetic energy when the water flowing through the orifice. Here is the equation in terms of height. This is equation 1 and this is equation 2. After we consider the pressure at point 1 and point 2 is equal, which is atmospheric pressure, we assume that the velocity at the point 1 is 0 because the liquid surface in the high story compared to the velocity at point 2. Consider the Z2 as a 0 at the datum point and the density is also same. So we will get Z1 equals to V2 square over 2G. When we rearrange the equation for velocity in Torricelli's law, we will get V2 equals to square root 2gz, or V2 equals to square root 2gh. That's all for my part. Thank you.
Hi, I'm Irfan. Let's continue with the discussion. The question 3 is given. Find the percentage of relative error for the theoretical and the experimental value. The question given two hints, which is the first hint is for the large reservoir with diameter which exposed to the atmosphere, a fluid leaves the nozzle with diameter which locate at the reservoir is considered as free jet, whereby the theoretical velocity of the flowing fluid depends on the gravity constant and the head difference between the center of nozzle and fluid at the surface of the reservoir. The equation given, theoretical value equal Z 2GH times M over S. The second hint is, under the same condition as the theoretical value, determination in terms of fluid head and fixed head of the nozzle to the ground, the experimental velocity when the fluid leaves the nozzle can be obtained by considering the maximum horizontal distance traveled, which is experimental velocity equal x times z g over 2y times with m over s. Or Torricelli relationship also can be verified using the measured drain time. The measured drain time is time taken to empty the fluid head difference between the center of nozzle and fluid at the surface. The measured or experimental velocity when the fluid leaves the nozzle can be obtained by considering the maximum horizontal distance traveled and measured drain time, which is experimental velocity equal x over drain time with m over s. So first, the percentage error between the theoretical value and the experimental value of velocity fluid is calculated by the equation, which is a percentage error P equal theoretical value minus experimental value over theoretical value time with 100%. So for the y equal for the velocity for the y equals 0.3665 meter, we get the average percentage error we get is 28.83%. Next, we move to the y equals 0.5645 meter, which is 56.45 centimeter. The average percentage error we get 28.62 meter. 28.62%. Lastly, we go to the 0.7615 meter, which is 76.15 centimeter. The average percentage error we get is 45.76%. Next question is find the source of error and method to minimize the error. First, we talk about error. The error that we obtain in this experiment exceeds 20%. Hence, there are quite a lot of error occur in this experiment. Maybe got error while collecting the data, such as eye of observer did not parallel with the reading. Next is when the nozzle does not point to the correct direction, which is in front, will cause the water flow in the wrong direction. And the lastly is leakage occur at the cylinder around the nozzle. This will affect the velocity of water. Next, the method to fix the error is we should take a few readings to get more accurate data. Next is make sure all the leakage are covered before the experiment starts. Third is place the tube at the end of the cliff so we can get more accurate reading of distance. And the lastly is minimize the systematic and parallel error as much as we can. Next, we move to the conclusion. In this conclusion, the experiment's goal has been met, that we conduct study to confirm the Torricelli connection by comparing compute velocity value of an hypothesis. Based on the results of the experiment, we may deduce that the velocity of water jet is proportional to the head of water. The velocity of water jet is related to the head of water. That statistic reveal an average error in different head of orifice from flow, with the average percentage error from the head 36.65 cm is 28.83%, while the average percentage error for the head 56.45 cm is 28.62%, and the last average percentage error for 76.15 cm, we get 45.76%. The percentage error in this experiment is fairly clear. We can show that reading the pressure is 100% measuring the pressure is 100% accurate, but we can minimize the reading error by repeating the experiment to achieve an average number. we should take the certain step to prevent making mistake that may affect of the reading. Next, the reference we used to make the report and the video. We get 3 references. Thank you. That's all for us.